Hear me?
Yes. Yeah, I can hear you.
Okay. Okay. We'll look at some inequalities and problems based on that today.
Okay.
Uh, the first thing is the trivial inequality. Basically, it says that x square is going to be greater than equal to 0, any perfect square.
Yes.
So, this inequality is also sometimes useful in problems. Like you might know it, but you need to be able to use it intelligently.
Okay.
So, for example, you can do a few problems on this. Like prove that for any non-negative reals root over x plus y times z plus w is greater than equal to root over xz plus root over yw. Second problem is prove that for any real number a square plus 1 times 5a square plus 1 is greater than equal to 4a into a cube plus a square plus 1. You should try out these questions right now.
Okay.
Yeah, these four problems should help you understand what we mean and how to apply the trivial inequality.
Okay.
What can you say about the first one?
First one, I squared both sides and then I got like the AMGM, so I just did that.
What do you mean you got A and G? If you square
I
both sides,
got,
what is happening?
no, I got, then I expanded, so I got XW plus YZ by 2 is greater or equals to root of x, y, z, w.
So you cancel these two, right?
Yes,
You're getting what? XW plus YZ.
yes.
How do you know that is correct?
Uh,
Why is that correct?
because, oh, so you want like, okay, because we can send it over to the other side and make a perfect square.
What is the perfect square?
Uh, One second. I think it's xw plus yz, root xw plus root
No.
yz.
Root XW, how can you do it plus?
Oh, minus, sorry.
The reason the
Root,
inequality is true is because the inequality can be rewritten as root over XW minus YZ is whole square is greater than equal to 0,
0. Yeah,
which is always true.
yeah,
So that is one way in which we have applied that some perfect square will always be greater than 0. At the end, that is the thing that has come,
yes.
right?
Okay, yes.
Second one,
Second one, I'm still doing. Second one, are we supposed to expand it out? Because after that, I'm not sure what to do.
expand it and bring it on one side, everything.
Okay, so I'm getting like a power 4 equation, degree 4 equation.
See what it means. It is not very difficult to figure out what those terms are.
Okay.
What is the equation you are getting power for?
I'm getting a power 4 minus 4a cubed plus 6a square minus 4a plus 1.
What is special about these terms? There is something obvious and special about this.
I'm not too sure.
You have
Oh,
never seen these coefficients.
no. Oh, it's binomial, I think.
You have to
Wait,
be able to
no.
spot it.
Oh, okay.
14641 you have never seen. Pascal's triangle,
No.
binomial theorem.
Oh, not like, yeah, I couldn't spot it, obviously. Like, it wasn't very obvious to me.
But it has to be.
Yeah,
Binomial theorem is basic.
yeah, okay.
The coefficients of the terms in this expansion would be a power 4 plus 4a cube plus 6a square plus 4a plus 1.
Yeah. So it's a minus 1 to the power of.
That will come with alternate signs.
Okay.
Pascal's triangle you heard of, right?
Yes, yes.
That's what the coefficients are here.
Okay.
This is a minus 1 power 4 greater than equal to 0, which is obviously true because now it is a square of a square.
Yeah.
So this inequality is true because the end we are getting something square is greater than 0,
Okay.
right?
Yes.
The approach for third problem is you should think of doing the proof by contradiction.
Okay.
Have you seen any proof by contradiction before?
Yes, yes.
So the question asks us to prove that at least one of these numbers is less than 1 by 4.
Yeah. So
At
just
least one
prove.
of them.
Yeah.
So if
So
you
you
want to
assume
prove
all
by,
are greater.
uh, uh, you'll say, let's assume all of them are greater than equal to 1 by 4.
Yeah.
That will give you some concrete steps after which you can do something. Otherwise, you will be stuck only.
Okay.
Contradiction is an easier statement to make
Yeah.
because if you try to prove it directly, there could be many cases, right?
Yes.
Just one of them is less, or multiple one of them are less. Which one also?
Okay.
You understand that contradiction makes a single clear statement.
Yes.
Now use this to arrive at something contradictory, right?
Okay.
We have assumed that all of them are greater than equal to 1 by 4. Now use these 4 to prove by contradiction.
Okay. Okay, I think I got it.
But
So I got I like added them all up,
mhm.
and then after that I got a square plus b square plus c square plus d square is less than or equal to a plus b plus c plus d minus 1. Then, yeah, from there, like, I don't know if we can just assume that all of them are like one term, which is the smallest one. Then you can bring them over to one side and complete, and then you have a square, which is less than equal to 0.
You're saying you bring all of them to one side. So if you do that, you'll get a square plus b square plus c square plus d square minus a minus b minus c minus d plus 1 is less than equal to 0. Now what
Yeah.
are you doing?
Okay, so like I thought of all of them as kind of just like we can write a square plus b square plus c square plus d square as 4 of something, because I'm not too sure if we can do that or not.
I don't know what you're saying right now. What do you mean 4 of something?
Like because we have 4 squares over here, so I just like took them as 4 of x squared, let's say.
How do you know they're equal? Is the
But
question
I
saying that all of them are equal?
no. But then
So how
okay.
can you write it
Wait,
as
so
4x squared?
like we can assume that a is greater than b greater than c greater than d, and then we can say a square plus b square plus c square plus d square is always less than or equals to the 4a square.
Okay. But
Yeah,
how
so
does
then
that help us like uh
because then it becomes a perfect square on this side, on the left side.
no it doesn't. If do you think it is wise to, if I have an inequality x minus y plus 1 less than equal to 0, should I replace x with something larger than it?
No.
Can I easily say that instead of x I'll put z minus y plus 1 less than equal to 0? Is it wise to do that?
Uh, no,
That's not allowed.
because okay.
Do you understand why not?
Yes, yes, because z can be like
Z
it can
can
be
be
greater than
such that
0
it
then.
becomes inequality is not solved then.
Okay. So what if we take the smallest of them? Does that work?
You can, but it doesn't help you solve the problem. Like
Oh, okay.
you definitely cannot say here instead of this, let's replace it with less than equal to 4a square. That doesn't work. If you do
Okay.
greater than equal to 4d
D
square,
square. Yeah.
but then like why are you complicating your own life by replacing it and all?
Okay.
Like what will you do for y term? This is
Then,
just too much annoying stuff to think of.
okay.
Which one you will replace it with? You realize what I'm saying?
Yeah, yeah.
This is not feasible to think of like whether I can do it or not. That's not the right way.
Okay. So can we try splitting it up, and then the one we can split it up into a few of 1/4s, right? Uh,
It is
wait.
obvious. That's what you have to do.
Yeah. Okay.
You can say a square minus a plus 1 by 4 and b square minus
Yeah.
b plus 1 by 4.
Yeah. Okay.
We are getting sum of 4 squares here, right?
Yeah. Okay. Got it.
Less than equal to 0. It cannot be less than 0, the sum.
Yeah. Because
If it
each
is
of them has
equal
to.
to 0, that is possible, but that would mean each of them has to be half. But the question said not all equal.
Yeah.
If not all equal, then it cannot be less than 0 also, or cannot be equal to 0 also.
Okay.
So which means that our assumption here is incorrect because now we have reached a contradiction which is impossible here.
Yeah.
Which means that one of them at least was less than 1 by 4.
Okay. Got it.
Do you understand?
Yes. Yes.
Okay. Fourth one. This is a single equation with three unknowns.
Yeah.
There is no
I'm
way you
trying
can
to
directly get the answer.
I'm
In
trying to group them together.
right, the
And
only way to do this question is by some trick, and the trick
yes.
here is trying to complete the squares.
Yeah.
So here, if I try to take 2 common, I have x
Yes.
square minus x. But what I need is a plus 1 by 4, right?
Yes.
2
So
common
when you
plus 1 by 4. So basically you have added half to it, right?
so you minus half.
So
Yes.
you should do a minus half here. So plus 1 minus half. For this,
Yeah.
you can take a 3 common, y square minus 2y by 3. And now technically it is a middle term of 1 by 3. So I should add a 1 by
1
9
by 9.
plus.
Yeah.
So technically I have added plus 1 by 3. So I should do a minus 1 by 3, right?
Yes. Yes.
Similarly, 6 z square minus 2z by 6, right?
Yes.
So plus 1 by 36 for it, right?
Yes.
So it is a technically a plus 1 by 6. So I should do a minus 1 by 6,
Yes.
right?
Yes.
And when you do that, you'll realize that 1 minus this is 0. See?
Yeah. It cancels out.
So now you're getting what? 2
We are
times
getting
x minus half whole square plus 3 times y minus 1 by 3 whole square plus 6 times z minus 1 by 6 whole square equals 0,
yeah.
which
Good.
immediately solves the question because now each square has to be 0.
Yeah.
X is half, y is 1/3, and z is 1/6.
Yeah. Got it.
Without this trick, it is not possible to solve this question because there is only one equation and three unknowns,
Okay.
right?
Yeah.
It is impossible to solve it if you don't use this perfect square trick.
Okay.
So again, we are using the condition that the sum of squares, perfect squares is positive and things like that, right?
Yeah. Okay.
Okay, so that is like a few examples on the trivial inequality, which is still quite important. Many places you will see it in problems. The next thing that we'll talk about is AMGM inequality. So basically, AMGM, it works on positive quantities only. Positive quantities only. And the general AMGM inequality would be x1 plus x2 plus x3. The arithmetic mean of n terms
Yes.
is given by
Yes.
this, and that will be greater than
Greater
equal
than.
to the geometric mean of these n terms, which is the 1 by nth power or nth
Yes.
root of the product.
Yeah.
So this is the AMGM version. Now you can also add an HM to it, greater than equal to. So technically it is AM is greater than GM equal to GM is greater than equal to HM. And the HM of n terms is basically the reciprocal. You know HM what it means?
No.
Harmonic mean you've not heard of.
No, no.
So harmonic series is basically a series where
It's an AP in the reciprocal form, like
the
1/2 + 1.
reciprocals are in AP.
Yeah.
So you are now saying what it is as if you heard it.
The harmonic mean is
The reciprocal series is in AP, then we say XYZ is in harmonic series. XYZ is in harmonic series means the reciprocals are in arithmetic series.
yeah, yeah.
So in the reciprocal series, which is an arithmetic series, what would be the arithmetic mean of the terms? The arithmetic mean would be 1 by x plus 1 by y till 1 by z divided by n, right?
Oh, okay.
This is the arithmetic mean of the reciprocal series,
Okay.
correct?
Yes.
Harmonic mean is defined as the reciprocal of this.
Oh, okay.
So the expression for harmonic mean would be n by 1 by x plus 1 by y till 1 by xn. Do you understand what I'm saying?
Yes.
So just like in a normal arithmetic sequence, we take mean by doing sum by total number of terms. We are doing the same thing, but we are doing it for the reciprocal series because that was that one was in AP, right?
Yeah.
So once you have found the mean of the reciprocal series, the original series is harmonic mean will be the reciprocal of that,
Okay. Got it.
right?
Yes.
So this is your HM of n things. If you
Okay.
apply it to two terms, only two terms are there. You will say x1 plus x2 by 2 is greater than equal to root of x1 x2 is greater than equal to 2 divided by 1 by x1 plus 1 by x2.
Yes.
If you look at this third term, that will come out to be 2x1 x2 by x1 plus x2.
Yeah.
For three terms, similarly, it will everything will be slightly bigger. X1 plus x2 plus x3 by 3, cube root of x1, x2, x3, and 3 by 1 by x1 plus 1 by x2 plus 1 by x3.
Yes. Got it.
The proof of these, at least in the two case and all, is super easy. You can just prove that this is bigger than this because
Yes.
x1 plus x2 is greater than equal to 2 times root over x1, x2. If you bring everything to one side, it is the perfect square of root x1 minus root x2 whole square.
Yes.
Because this inequality is always true, we can go back like this and prove that this is true.
Okay.
The equality case happens in the AMGM HM inequality when all the terms are equal.
Okay.
If each of these terms are equal to each other, then obviously the arithmetic mean is the same as any one term, right?
Yes.
And the harmonic and the geometric mean also is the same term if you think about it.
Yeah.
x1 power n whole to the power 1 by n.
It's x1. Yes.
And here this term would be n by x1. So it is going to be x1 again, right?
Yes.
So all three means are becoming the same thing if all the terms are equal.
Okay.
Do you understand?
Yes.
So this is AMGM HM inequality. Now only works for positive things. Don't try to apply it if you don't know whether it's guaranteed to be positive.
Okay.
It will not work if any of the quantities could be negative.
Okay.
So the question is, there are three non-negative real numbers, three non-negative real numbers x, y, z. Prove that x cube plus y cube plus z cube is greater than equal to x square y plus y square z plus z square x.
Okay.
Try to think how you can get the terms like x square y, y square z, z cube x, z square
Yeah.
x, and so on.
Okay.
So what I would suggest here is in order to get this term,
Yeah.
you need to do AMGM, but on what should I do AMGM? That's the main thing, right?
Yes.
AMGM looks like this for three terms. X1 plus x2 plus x3 by 3 is greater than or equal to cube root of x1, x2, x3.
Yes.
How can I generate an x square y term, which will obviously be somewhere here?
Uh, You can take two x's and one y.
Hmm. Correct?
Yes.
If you take the product here and cube root of this, that will clearly be x square y.
Yes.
So we know this is greater than x square y by AMGM.
Okay. So you can repeat
Similarly,
this
I
now.
can say y cube plus z cube by 3 is greater than or equal to y square z.
Yes.
And finally, z cube plus z cube plus x cube by 3.
Greater than z square.
So in this case, it becomes z square x. And now, if you add all of the left-hand sides here, right,
Yes.
you are getting 2x cube here, 1x cube here. So you're getting 3x cube, 3y cube, 3z cube by 3.
Okay. So it becomes,
So
yeah,
it is
got
just the
it.
proof of this, right?
Yes.
Again, you have to be smart about how you're applying AMGM, where you're applying. Whenever you see
Okay.
a product term, you have to think, can I get it through some sum terms and all somehow,
Okay.
right?
Yes.
The next major inequality, very important, is Cauchy-Schwarz inequality. This goes like this: a square plus b square times c square plus d square is greater than or equal to ac plus bd whole square.
Yeah.
On three terms, you can do it like this: a square plus b square plus c square times x square plus y square plus z square is greater than or equal to
Yeah.
ax plus by plus cz whole square.
Yeah.
Whole square. And it can be generalized to n terms also if needed, right?
Okay. Yes.
This inequality, why does it make sense? And also, what is the condition when it is an equality? So the condition for
The
equality
ratio.
should is
The
that
ratio has to
the
be the same.
series of numbers here have to be having the same ratio, right?
Yeah. Yeah.
A by x should be equal to b by y, should be equal to c by z, should be equal to d by w, and so on.
Yeah.
Depends on how many terms you have. How many terms are there in this series of numbers and in this series of numbers.
Yes.
But why is all this happening? Why is this inequality correct? How?
The dot product
Right.
is, yeah.
So basically, if you have done any little bit of vectors also, you can say A vector, B vector can be written in 3D space or sometimes even ND space. In 3D
Yes.
space, you can write it as A1i and A2j and A3k, right?
Yes.
And similarly, B vector you can write as B1i plus B2j plus B3k.
Yes.
Now we know that mod of A is going to be root over A1 square plus A2 square plus A3 square.
Yes.
which is just the length of the A vector. And similarly for mod of B would be root over B1 square plus B2 square plus B3 square,
Yeah.
right?
Yes.
So if I do mod of A square into mod of B square, mod of A square into mod of B square,
Yes.
that is going to be equal to the product A1 square plus A2 square plus A3 square times B1 square plus B2 square plus B3 square.
Yes.
So this is what you got at the left hand side of Cauchy's inequality. Now let's
Yeah.
try to figure out the right hand side. So if you do A dot B, what are
Yes.
you getting? You are getting A1
We get
B1,
plus
A2
two
B2,
B2, A3
A3
B3.
B3. This is the dot product of A and B vectors, which can be written
Yes.
as mod of A mod of B cos theta.
Cos theta. Yes.
So
So
this is
cos
just the
theta is
dot
always,
product, and cos theta is always less than or equal to 1,
yes.
which means that A dot B is less than or equal to mod A mod B.
Yes.
And
Got it.
that's how it is. And therefore, if you do A dot B, which is always the RHS of the Cauchy inequality,
Yeah.
that will
So,
be less than or equal to the product of the magnitudes.
yes. Yes. Got it.
Okay.
Yeah.
Then let's do a couple of questions. Find the minimum value of nine x square sine square x plus 4 divided by x sine x, where x is between 0 to pi. This is the fifth problem. And sixth one is if x square plus 3xy plus y square equals to 60, where x and y are real, find the maximum possible value of xy.
First one is the answer 12.
How?
You can split it into two squares and then do AMGM.
Tell me
It's
what you
3x,
did.
it's 3x sine x whole square plus 2 square upon 2 is always greater than equals to 2 into 2 into 3x sine x. And then after that, you can just get the x sine x down.
Fine. 12 is correct. The reason it works is because sin x is positive in 0 to pi.
Yeah,
Okay, next.
yes, x.
The sixth one is not very difficult.
Yes, I'm getting 60 by 7. Is that correct?
No, you made some silly mistake.
Oh,
If you see x square plus y square are the only things that are guaranteed to be
yes.
positive.
Yeah,
So
so
we
you
know
can do
that's
this
greater than
AMGM.
2xy by AMGM, right?
Yes, yes.
So we can say 60 is equal to x square plus y square plus 3xy, and this is greater than equal to 5xy now,
Oh,
right?
yes.
Because this is bigger than 2xy, right?
Oh, okay, okay. Yeah, yeah.
So we are getting clearly 60 is bigger than 5xy, so xy is less than equal to 12.
Yeah, okay.
So it's very easy application, right?
Yes.
Third one. Expand it.
Yeah, okay.
We have to show this.
Yes.
We can do that. We need to show 1 plus x plus 1 by y plus 1 by xy is greater than equal to 8. So we can
Yes.
take xy common denominator. Here it is x plus y on top plus 1 by xy. Uh, x plus y is 1. So this is like a 2 by xy, right?
Yes.
This expression is 2 by xy. We need to show that 2
Yes.
by xy is greater than equal to 8, right?
Yes.
So technically we need to show 1 by xy is greater than equal to 4,
Okay.
right?
Yes.
So if that means we have to show that both are
XY.
positive, so we can say xy is less than equal to 1 by 4.
Yes.
So
Okay.
from here we can say x plus y by 2 is greater than equal to root xy, and we
Yeah.
already know this is 1 by 2, right?
Yes.
1 by 2 is greater than equal to root xy by a and gn. So obviously xy is less than 1 by 4.
Yeah, got it.
Do you understand?
Yes. Yes.
You have to do slowly, step by step, you have to figure it out, right?
Yeah. Yes.
So I'll give you a couple of questions. You can try it for tomorrow. Uh,
Okay.
and tomorrow we'll do problems only. So question is,
Okay.
if A, B, C are real numbers with A minus B is equal to 4, find the maximum value of AC plus BC minus C square minus AB. Uh, then
This one, do I do
another
it now or do I do it
tomorrow
at home?
at home.
Okay. Okay.
Then another question is, um, solve in positive real numbers, the equation x square plus y square pi 1 plus xy is equal to root over 2 minus 1 by xy. And second, you have to prove ABC are real and greater than equal to 1, all three of them. Prove a cube plus 2 by p square minus p plus 1 plus b cube plus 2 by c square minus c plus 1 plus c cube plus 2 by a square minus a plus 1 is greater than equal to 9.
Okay.
Okay. These three questions try for tomorrow.
Okay.
And anyway, like we'll do more questions tomorrow. Okay.
Okay.
Fine. Just practice. And if you're done with them, practice more questions. More you do questions, the better it will be.
Okay.
Not just on inequalities, on the normal polynomials and equations and sequence and series, all of it.
Okay. Yeah.
If you are not able to find questions, do AMC 10, AMC 12 algebra.
Yeah.
AMC 10 and AMC 12 algebra is at the level of your exam.
Okay.
So do that if you're not finding enough.
Okay. Sure.
Okay, fine.
Okay.
That's all for
Oh,
now.
okay. Thank you.
Mm,
Bye.
bye.